Hello everyone, this is Webboot. We're the intern from the Google. I am Shiyu, a CS master student from the University of Southern California.
And I'm Gabriel Biren. I'm currently working on a master's in computer science at UCLA.
So the Webboot is an open source tool that could boot live OS distros from the web. It could either boot ISO from the local or from the website by downloading it first. And the Webboot is part of the uroot project, which is a part of the Linux boot. The code is written in Go language, and we use some passages from the uroot. The source code could be found at the GitHub. And there are two scenarios you may want to use a Webboot. The first is when you want a multi-boot USB stick to help you quickly switch between different OSs, like you want to test something in different operating systems. And when you want a one-time use operating system, that is after you work, every information will gone in one left in the device. That may happen when you land the laptop or you want to do some sensitive work in unsecure environments. And there are some advantages of the Webboot. The first, we give it a UI, so even the non-professional user could easily use it. And the second is we provide a convenient way to manage the OS. That is, you can easily add a new ISO to the cache or remove an old one. And the third is, since we will not actually install the operating system to the disk and all the file systems are run in the memory too, after you close the device, everything will gone. It wants some information left on the device.
So the original concept for Webboot looked something like this. So in the first step, we download a Linux ISO. After that, we copy the ISO to a persistent memory device. And persistent memory is kind of complicated. But the thing to think about is that we kind of allocate a region of memory and treat it like a block device. And this will be important later on. So in the third step, we retrieve the ISO's kernel and initial RAM disk. Then we use kexec to start running that kernel and start booting into the new distribution. And in the fifth step, the new distribution is initializing. And at this step, the distribution locates the persistent memory device. And inside that device, it finds the ISO, and it grabs the files it needs from there. So last year's interns presented Webboot at Open Source Firmware Conference, and they had some pretty good results. So they were able to boot into a modified TinyCore ISO. And the main modification is that they recompiled the kernel with persistent memory support. And this kind of points at some of the problems. So the main issue is that most distributions don't actually support persistent memory by default. And what this means is that when that distribution boots, it can't find the persistent memory device. So it loses the ISO. And instead of booting the full live distribution, we end up with the recovery shell. Another issue is that persistent memory is difficult to work with. One problem is that we need to know the size ahead of time. So for instance, we allocated 1 GB of memory, and the ISO ended up being bigger than that. The rest of the issues needs to re-download the ISO every time you run Webboot, which adds some delay to the beginning of the process. And the other thing is that Webboot was command line only, which isn't very friendly to users who don't know how to use the command line, or if they don't know the arguments they need, or any of that.
So what we did this year is first we build a UI system. This UI is built based on a library called term UI, and we did 3 basic components for the UI. The first is a menu, and second is the input box, and third is a message box. They have some common features that they all support the multi-hierarchy, and they all could return to the last step. And the menu and the message box that support the mouse scroll or the page up, page down operation. So the UI components looks like shows on the right. The menu is consists of the title and the list of options and the input box to indicate which option you want to choose. Since the option list may be very long and it cannot be shown at the screen by one page, so you can scroll up and down to see the whole list. And the input box allow user to input something. This input box have a function called isValid to check if the input is valid or not. That is, if this input box are asked for a website address and you input something like 1, 2, 3, 4, 5, it will say it is invalid. And the third is a message box, which will display some messages and alerts that user need to know. Since the message may be very long too, you can use the mouse scroll or the page up, page down to turn the page. And you can use the home and end key to jump to the first page and the last page. And the download process bar is a special type of the message box, which when we establish the connect to the download link, we can get the whole size of the item we want to download. And since the download process will break the item into piece to piece and download each piece at a time, we can get the size of each piece and calculate the download process as a percentage and dynamically update the content of the message box. So it will look like the message box updated itself. And we also give a unit task to the UI part. Since the UI asks for users' input to interact with the program, the biggest challenge is how to simulate the user input. Since directly simulate the keyboard and mouse interrupt events is too complicated, we found the alternative way to do so. That is because we use the term UI to build our UI, and the term UI will pass the user input into a channel, then read from the channel. So our idea is to replace the channel with our test channel in the test. So in the test, we will not directly use the term UI, but we will call the term UI some function to let it read from the test channel. And so in the test, it could like read the design channel, read the design input. And the UI test really catch some error in front of the user did. Like this case, since the menu is only can only display 10 options at a time. So we have a logic that says every time we will cut the first option and the last option in the page and check if user's input is inside this range. That is for make sure that the user input will not exceed the number of the option. But we found a case that is when they originally have 10 options in the list, and we add a new one to the list, and we want to test the new option in the test. And if we call the last option directly, since this option is not displayed in the current screen, the program will throw out an error that so this UI logic is very confusing since the option 11 is existed, but it cannot be called. So the UI test caught the UI logic problem before the user did. And after this, we reconsidered the UI decisions. And now we allow user to choose any existed options, even if it's not currently on the screen.
So another change this summer was to the Wi-Fi settings. So in the original version of Webboot, we had to set up a Wi-Fi connection before we even started Webboot. We did this with a command line utility that was kind of tough to use. So because of this, we decided to integrate Wi-Fi setup into our menu flow. And this really breaks down to 4 big steps. So in the first step, we scan for networks. When this finishes up, we present the user with a list of available networks, which you can see on the right side. Next, the user selects the ESS ID of the network they want to connect to. And depending on the security setup of that network, we collect somewhere between 0 to 2 credentials. After the user enters all of that, we use that information to connect to Wi-Fi, and then we go to the download screen. So another big change this summer was the addition of a local cache. So in the original Webboot design, we had to download the ISO every time we ran Webboot, which is kind of undesirable if you have something like Ubuntu that's 2.5 gigabytes. This means that even at 2 megabytes a second, it takes 20 minutes to download the ISO every time you want to boot Ubuntu. So we decided to add a local cache to avoid this problem. And what this looks like is we added a directory called /images on the boot device. And now when the user runs Webboot, they have 2 options. So either they can download an ISO and save it to the cache, or they can retrieve an ISO they've already downloaded and boot from that. The third big change is that we had a lot of problems with persistent memory. So we wanted to get around using it. But the issue is that persistent memory played a really important role in the original Webboot setup, just because it acted like an emulated CD containing the ISO. So if we got rid of persistent memory, we had to find a new way to direct the booting distribution to its ISO file. What we found is that there's a kernel parameter called isoscan file name, which is available to a lot of Ubuntu-based distributions. And if you check out this example at the bottom, it looks something like this. So on the left side, we have the name of the parameter, which is isoscan file name equals. And on the right side, we have a path to the Ubuntu ISO. And what happens is that when Ubuntu boots up, it will start mounting the devices, and it searches for this path on all the devices. And if it finds that path, it'll mount the ISO and grab the files it needs from there. One thing to note is that isoscan file name is kind of specific to Ubuntu-based distributions, but we found that there's an equivalent for most of the main distro families, which can be found in this table. So the new boot process looks something like this. So in the first step, we'd select the Linux ISO, either by downloading it or retrieving it from the local cache. After that, we mount the ISO and we parse the config file. This allows us to find the kernel, the initial RAM disk, and the kernel parameters. In the fourth step, we go to that lookup table for the previous slide and find the isoscan file name or that equivalent parameter for that distribution. And we append it to the parameters we found in step 3. And in the fifth step, we use kexec to start booting the kernel and to boot into that new distribution. Okay, so right here, we're going to invoke the Webboot program. So right here, we're at the main menu. We have 2 options, either download an ISO or grab one from the cache. So I'm going to select 0 to grab it from the cache. This is all the ISOs that are on the disk. I'm going to select the Ubuntu ISO. These are all the boot configurations, and we're going to use the live CD mode. Okay, and we're in Ubuntu now. So it does some disk checking just to make sure the ISO is okay. This takes up a lot, so we're just going to skip a bit.
Nice. Skip to...
Yeah, and yeah, we end up in the Ubuntu desktop. So we did a lot of work this summer, but we have some goals for the future. The first thing is that we want to support additional distributions. We currently support 10 distributions from some of the main families, including Arch, Debian, and Ubuntu, but there's always room for more. Another thing is that we want to verify the ISO checksums, just that when the user boots up an ISO, they know they're using a valid copy of the ISO. And kind of the far-off stretch goal is to include Webboot in the uroot init process. And what this looks like is that when you power on your computer, the computer would start running uroot, and when uroot finishes initializing, it would start running Webboot. And what this means is that from the perspective of the user, they power on their computer and they go straight to the Webboot menu where they can select the OS they want to boot. And the last thing we want to note is that we're always looking for new contributors, and the link to our repo is available here. So we just want to say thank you to everyone, especially to our hosts, Rod Minnick, Prachi Lad, and the Nerf team. So thanks.
Thank you.